All right, so in chapter 12 here, we're dealing with data, basically, is what it comes down to, and how we look at data and discuss it and make decisions and so on. And so when we do that, we have to talk about populations and samples, which is how we collect data in the first place, and where are we collecting that information from, and what is it about. So for example, let's start with some of the definitions. Population. The population is the entire group of subjects or objects or individuals considered for a survey. Okay, so in this particular case, we're going to be talking over the next few slides about the population of elk in North America. So we're talking about all of the elk that happen to fit or be on the continent of North America. That is our population. So as a discussion item, in 2002, there were claims that chronic wasting disease, CWD, or mad elk disease, was spreading westward across North America. In order to verify claims such as these, the elk population had to be tested. How is such testing for CWD conducted? And so, in this particular case, and we're going to get into some of the, not some of the specifics, but of some of the ways that we have to compare data, collect data, and do we have things like bias and so on that are thrown in. So we're going to be talking around this idea of chronic wasting disease and mad elk disease in our population in North America. So first of all, sample. Okay, sample is a part of a population. So in this particular case, it's the portion of elk that are captured for testing, because one of the things we have to understand is generally we cannot collect the entire population. Okay, we cannot usually survey an entire population because usually there are just too many. In this particular case, if we're talking about elk, it is literally impossible to capture all of the elk. So we have to do sampling. We have to just test a part of the population. Okay, so if we're taking a part of a population, we are taking a sample. But then there are different types of sampling. Okay, we have random samples, which is a sample in which individuals or objects in the entire population, or each object in an entire population, has an equal chance of being selected. Okay, so we randomly go out and pick objects from the entire population to be sampled. Then we get into all things sometimes are what we call convenience samples, and these are samples based on members of the population that are readily available. Okay, and what that means is we're here in Michigan. Okay, it would be convenient for us, because we do have elk in the northern part of Michigan, for us to simply go north and to test the elk in northern Michigan. Well, the problem is those elk may not be representative of the entire population. What about the elk out on the Great Plains? You know, so for us it would be convenient to go to the northern part of Michigan and to conduct our experiments on our elk here. The problem is they may not have the same issues as the elk out west. What if this disease, the chronic wasting disease, hasn't gotten here? Well, even so, we would be testing elk that are convenient for us to get to. All right, so let's determine which sampling measure would be better to represent an entire population. So in this particular case, we're talking about football game student attendance, and we have a couple sampling methods. So Arnie surveys 80 students by randomly choosing names from the school directory. He finds that 62% attend football games. Vic, however, surveys 28 students that are sitting near him at lunch. He finds 81% attend football games. Does one method of sampling result in a better picture of the entire student population? And I hope when you read these two methods that you realize that Arnie's method, in this case, if we want a true result of what is actually happening, Arnie's sampling method is the better method, because the randomly choosing names from the directory gives us a better picture of the overall sample. Okay, Vic he has gone with a convenience sample of sampling. Okay, and so and you have to think about, well, what if Vic himself is a football player? Well, in schools and so on, people tend to sit by people and associate with people who they have similar interests to. So Vic, if he's a football player, is probably going to sit near more football players. So it's pretty obvious that probably more people around Vic in that case are going to go to a football game, where Arnie, maybe he's not a football player, is probably going to sit by more non-football players. But in this case, by choosing people randomly from the school directory, he gets a better cross-section of the entire population. So in this particular case, the random method, Vic's method, or Arnie's method, is a better sample, R-A-N-D-O-M. Okay, and in this case, that's done by Arnie. And we have to think about those things, okay? As far as if we're actually going to be doing some surveying, how can I get the most reliable set of information? We also have bias samples, and a bias sample is a sample that does not fairly represent a population. Usually, convenience samples are somewhat biased. Again, if we're talking about Arnie and Vic, again, if Vic is only going to ask football players, for example, a certain question about something, well, those answers are going to be skewed in the direction of how football players think. Where in other cases, if we can get a larger group and represent more groups, our information will be a little bit more reliable. So we're going to talk quickly here about possibilities of biased samples. Okay. So A, the first 50 people exiting a movie are surveyed to find out what type of movie people in the town like to see. Is there a bias? Okay, so you're standing outside the movie theater, and the latest Iron Man movie is on the screen. And so you're standing outside, and the Iron Man movie gets over, and people are coming out, and you ask the people as they come out, what is their favorite type of movie? And what is the favorite type of movie for people in this town? Is there a bias? Well, probably if you're standing outside of an Iron Man movie, there is a bias. Why? Well, probably because the people in that particular situation are people who like superhero movies, like action movies, and so on. Okay? So yes, there is a bias toward a particular outcome in that case. And in this case, yes, it's probably going to be toward superhero movies and those types of things. Okay, or those types of movies. I guess I shouldn't say superhero movies. So I should say that type of movie in this particular case. The question itself is not specific to superhero movies. It could be if you're looking at you go to the latest romantic comedy. All right, the people that are coming out of that movie probably like romantic comedies. Okay, so they're going to be, in this case, oh yeah, I like romantic comedies. Well, there's a lot of other people in town who may not like romantic comedies toward that genre. G-E-N-R-E. That's supposed to be an N. In this particular case, a librarian randomly chooses 100 books from the library's database to calculate the average length. And is there a bias toward one? And the answer in this case is no. And basically when you have a random sample, a lot of times you are going to not have bias. By doing things randomly, typically you take bias out. So, verifying claims based on statistical data. So now we're going to throw a little math in here real quick. So, a biologist estimates that more than 700 of the 4,500 elk at a wildlife preserve are infected with a parasite. A random sample of 50 elk shows that 8 of them are infected. Determine whether the biologist estimate is likely accurate. Okay, and we're going to do this in using a proportion. Okay, so in this particular case, we're going to set up again a proportion that that compares the sample data to the population data. So, infected elk in the sample. So in this particular case, we had 8 elk that were infected, and our sample size in this case was 50 elk. Okay? And we are checking to see, in this case, is that equal to the infected elk, the possibly infected elk, which is 700, in the entire population, which is 4,500. Okay? And so now, again, we get into, in this case, how do we compare fractions? And so you have choices. One, you could, and this is going back to previous chapters, you could reduce to lowest terms, okay, if you want to, and see how close they are. 2, you could put them into common denominator formats, for example. And in this case, I think I'm going to go ahead and do that. 4,500, let's see, 50 goes into 4,590 times. So I am just going to do this. I'm going to multiply by 90 here and 90 here. And so this will be over 4,500. And if these are equal, our numerators should end up being the same. Or you could change them both to decimals if you want to. Maybe I'll do that here in a second. 8 times 9 is 72. Tack on my 0 there. 720. 700. Now understand here, these are just estimates, okay? So is 720 sort of close to 700 out of 4,500? In this particular case, because we're estimating, I'm going to say yes, accurate. Okay? For an estimate, this is okay. Now, if it wasn't an estimate, then we would want them to be exactly the same. But in this particular case, we're probably okay. Now again, if you didn't want to do fractions, excuse me, we could do decimals. All right. So I'm going to, and I'm just going to use a calculator. If I go 8 divided by 50, the decimal representation of that is 0.16. Okay. 700 divided by 4,500 is 0.156. Oops, sorry, 15. Actually, it's 15 repeating. All right. So here, actually, let me do this correctly. And so when we're talking about, especially an estimate, and we go, well, 15 or 16, 15 repeating. Well, 15 repeating, if we went to 2 decimal places, would be 16. And at that point, they're going to be accurate, or even. They're going to be the same. So if we're talking about estimates, yes, these are close enough for what we're dealing with. So again, you have your choices: fractions, decimals, percentages, common denominators, reduce them to lowest terms, all of those things that we do with fractions you can, in this particular case, deal with. So I'm here for help. Please come see me when that happens. All right, samples, populations, go.